All right, I'm going to talk about the waves lesson and the Nearpod that we assigned on Monday and Tuesday. Just going to show you how to get there. First of all, we go to my modules, come down, look for the waves lesson, open that up, and you will see a few different things appear. There's a link to Nearpod at the top, including the code 3WDMS if you need it. Here's the Nearpod. You can do it right in Canvas, I do believe. Um, then I'll just mention right now, I'll come back to them. There's a few things that don't quite work right in the Nearpod. There's a couple of links to some definitions that are given. Here's the actual functional links. And here's a link to the PhET simulation, which looks like the picture down below there, by the way. We're going to need that as well. Slides 9 through 12 are supposed to be animated GIFs, but they don't work. So I've included a slideshow from another year that has all the functioning animated GIFs, as well as many definitions of features of a wave. They're probably better than actually referring to the physics classroom or math is fun if you're just looking for some straightforward definitions of the features of a wave. Flip through this slideshow. Maybe I'll get to it after the Nearpod. But I just wanted to let you know that stuff is there for you. So here's the Nearpod. That's not what I want at all. Preview. All right. Let's dive in here. What is a wave? You can read it to yourself. This was probably supposed to be animated. Look for some wave in the slides and the canvas. Here, I'll do it right now. Let's go to, there's a nice transverse and longitudinal GIF for you. Here's another transverse wave. I think this is what I really wanted to get to. All right. Exploring waves. We're going to look at a simulation, spend some time poking at it. Try to think of some things that we could investigate about waves. See what you can do. Make it do something crazy. It will, I promise. So we go to our simulation. Here it is. Right now we can grab our wrench. You can see we make some waves. We can change a bunch of things. I happen to like the oscillate setting. Does that nice thing. Blocking some of this. Oh God, what am I going to do with me? Get me out of the way. Over here somewhere, I don't know. We can change the amplitude. Look at that. What's that do? We can change the frequency. Turn off the damping or increase the damping. I'm going to leave it turned off. What's turning off? Changing the tension. That does some crazy stuff. We can change it from a fixed end to a loose end. Let's reset this because it's getting just out of control. You can see the difference between a fixed end and a loose end, or no end, which is really what we're going to probably be using most of the time. You can turn on rulers. You can set a timer. That might be useful for measuring wave speed. A bunch of stuff you can do. Play with it, make you go crazy, report back. Next slide. I'm going to move myself out of the way. Watch the Bill Nye video. Enjoy it. Next slide. Okay, here's those two links I mentioned. If you want to actually go to those links, go back to the canvas, find those links, click on them, go to the next thing. Here is a matching. I'm going to match two tiles here to each other. So what is the period? I'm going to try to match the period to something. Oh, I don't think it's any of these. How many seconds it takes to make one wavelength? Is that a period? Yep, I was right. Nice. Match the rest of them. You may want to refer to my definitions, the links in the slide in the canvas, or the slideshows in Canvas, or you can look at the links for the other two things. Righty, what do we got here? Another video. Watch the video. Hope you enjoy it. This is the GIF animation that I was intending, or that I was saying. These things don't work. So if I go to my waves definitions, these are the slides that are embedded in the Canvas page. You can open them as a separate thing if you want to. Here's our nice longitudinal and transverse waves. Longitudinal on top, transverse on the bottom. Here's another different kind of transverse wave. You can see the particles are moving vertically up and down on your screen while the shape of the wave seems to move from left to right. Meanwhile, longitudinal waves are like, they're all in the same line. Everything's moving left to right. So this, you could imagine this is like the diaphragm of a speaker moving. Maybe you've seen a subwoofer move like this. And when it moves to the right, it kind of piles up a little pile of denser atoms or molecules or whatever they are. They, and that little pile, even though the actual molecules don't move, that pile kind of shifts to the right. I'm following with my cursor. But if you look at the red dots, you'll see they just move back and forth. They're not actually going across. So we've got this, that's the nature of a longitudinal wave. So you can see, I was just saying this, the wave itself moves left to right, but the particle just goes back and forth. We call the dense parts compression, and we call the thinner parts rarefaction. Great word right there, rarefaction, the less dense areas of this kind of wave. All right, we can compare them here. I like these. Here's an ocean wave. This is a combination of longitudinal and transverse. So you can see any given piece of the ocean is going up and down in a circular path. So some of this is vertical, transverse style, and some of it horizontal, longitudinal style. You'll also notice that ocean waves really happen at the surface. If you go down a little ways, the particles aren't really moving. If you were a scuba diver swimming around down here, you wouldn't feel the waves. You'd have to go right up to the surface where you'd be bobbing up and down. Similar thing happens with an earthquake, what we call seismic waves, although they move more up and down than they do back and forth. So we get these oval shaped motion, mostly transverse, some longitudinal. So those are the slides I wanted to show you regarding sort of animations of waves. It gives you some visualization of the properties of waves or the nature of waves rather than these non-functional slides. All right, what do we got next? We're going to try to do something a little bit more serious with our simulation, PhET simulation. I want you to have it set like this: oscillate, no end, amplitude of 0.5, frequency of 1.5, damping none. Tension high, ruler and timer on. So we're going to go no end, oscillate, amplitude of 0.5. You can click on there to get one more over. No damping. Tension high, rulers, timer on. So set that up like that. And well, first thing you're actually going to do before you need to use that is put some definitions. I would go back to my slides. Above all those nice animations, I can show you a crest and a trough, both peaks, a wavelength from crest to crest, or trough to trough. Here's some descriptions. The period of a wave is how long it takes the piston to go up and down one complete time. So if we look at this, period is one rotation of that little wheel. I'm going to put it in slow motion so we can see it. It goes around from up to down, back up again. That's a period. And the frequency, that frequency right there is how many times that happens in a second. 1.5 rotations per second, 1.5 rotations per second. It's also how long it takes a wave to pass by a fixed point. Another way to think about that. Well, that was not intentional. Frequency is a related concept, but it's how long, how many whole waves will pass by in a second. So 1.5, if we had this normal pace, 1.5 whole waves will flop out the window in 1 second. 1.5 will form every second. Whoops, I meant to go back to my definitions here. Wave speed, how fast does a peak travel from its formation out the window? I'm going to figure out how to measure that perhaps. And amplitude is how far the wave deviates from what we might call equilibrium. the place, if we were to not have any wave action at all, we're going to turn our amplitude down to nothing. There's no wave happening. How far does it deviate the amplitude? It's how far it goes from that dotted line. So when I set my amplitude of 0.5, whoops, that wasn't 0.5 at all. You will notice that it is 0.5 from the middle to the bottom. It's also 0.5 from the middle to the top. The top to bottom, which is not something we usually talk about, it's both of those 0.5s. It's a whole centimeter. All right, so you're going to do some sketching on here for yourself. I don't know if I can do this for myself. Maybe. Oh, I can. Look at that. Let's erase that. Can I erase it? Oh, I don't even know the tools here. Look at that. I can erase it. Haha. So let's go in here and make sure I got my marker. As it gets smaller, I got to move myself out of the way again. Or I'll go up there. I think I can make it a little small. Oh, I can make it quite a bit smaller. Okay. So we're going to label like a wavelength so that we can go from here to here. Oh, that's a wave length. Huh, that's fun. And we got amplitude going down or amplitude going up. It's both of these. Whoops, that wasn't what I meant to do. That's amplitude, and that's amplitude. There's some other ones. Which direction is the wave moving? Which direction are the green dots moving? What's a crest? What's a trough? What's equilibrium? There are some other ways you can approach this. I know I happen to have this nifty tablet, but if you wanted to do it with just your mouse and you can't spell things out like that, color code things. Go in here. Let's make our pen kind of big, not that big. And we can say, well, I'm going to make my wavelength blue. So I'm going to circle this. Wavelength is blue. And I'm just going to draw, like here's my blue wavelength, something like that. And then we know by color that the wavelength is blue. We can make our amplitude red. So we do this, amplitude is red. I'm just doing this with my finger on the mouse pad. Amplitude is red. So you can do that. You can mark it with an A. And we can do our wavelength with a W. I know I'm going right over top of my nice handwriting there. So however you can, do it on up. All right, what's next? A quiz. I didn't really prepare for this, but it was awfully inconvenient trying to modify this Nearpod. All right, does amplitude affect frequency? Oh, how do I know? Let's go back and look at our simulation. Let's make it go again. Why isn't it going? There it goes. Get myself. Oh, I can like stare. I don't know if I can make my eyes do it. Which direction do I need to look? Like over there. Looking at the wave. I don't know. Anyway, so does amplitude affect frequency? Well, look at this. I'm gonna change the amplitude. Did the frequency change? Look at that. I'm gonna change the frequency. I mean, I didn't ask that, but is the frequency changing when I change the amplitude? No. So that's an easy one. Where'd it go? It did not. I think I click here to the next question. Does amplitude affect wavelength? That's a trickier one. You got to go in here. Let's make our amplitude smaller. Pause it. Play it a little bit. I'm going to get a nice full crest to crest that I can measure. I'm going to measure it. Play it. I'm going to increase the amplitude all the way up. Get a nice crest to crest. Measure it. What did it say? Did it change the wavelength? You figure it out. Um, what's the next one? Does amplitude affect wave velocity? This is the hardest one to figure out here. So I'm going to move that ruler out of the way, get this going. I'm going to get it going in slow motion. And I want to know, velocity is distance over time. So we know that if something takes longer, it's going slower. It takes longer to go the same distance. So let's consider how long it takes a wave to go from its formation, from 0 point here, out the window, like that. So we're going to time that. We're going to use the stopwatch. We're going to watch a wave form. I don't have two pointers. I need a pointer to point and a pointer to click. So I'm going to watch the window. I'm going to watch this wave move. I'm going to start it when that green bead gets to the top. And I'm going to watch that wave go. I'm going to time it. Go. And it's out the window. All right. And then I'm going to make the amplitude much less. I'm going to do the same thing. I'm going to bring this down right here, right there. It's easy to measure, easy to see. Probably don't even need the ruler. Whatever. Reset my stopwatch and time it from formation to out the window. I'm not going to do it for you because you got to figure it out for yourself. What effect does amplitude have on wave velocity? All right, last question, open-ended. In your own words, summarize the relationship between amplitude and frequency slash wavelength slash wave speed for each of those. What is the relationship for between amplitude and each one of those? Just like in our questions or short answer quiz, explain it a little bit or summarize it. That is that. So I think I've done my wave lesson. Do your Nearpod. It'll be fun. See you in class.